I will show you how to find frequency of the alternating current that we received in our homes. So the frequency that we receive in our homes is at 50 hertz, right? So that's what we are going to find out by using this sonometer arrangement. So this is a sonometer, okay? This is a hanger. Hanger has a mass of 500 grams, and I have added another 500 grams. Now it is 1 kg of mass that is hanging from here. So this wire is passing over the pulley, okay? So the stretched wire, and we know that resonant frequency of this wire we had actually done in +1 also. So that was by using the formula, that is 1 upon 2L under root T upon M, right? So where, as you know, is the length of, that is the length between the resonating column, and T is the tension, that is here it is 1 kg, that will be multiplied with the 9.8, and you will get in newtons, that is the tension we have applied on the string, and the M is mass per unit length of the wire, right? This here is a transformer that we are using, okay? So you can see this transformer output is then supplied to the electromagnet. This is an electromagnet which I have clamped in a stand. These are two wedges, right? These wedges are placed very close to each other initially, and the arrangement is fixed so that the electromagnet is at 50. There is a marker from 1 to 100 centimeter on the sonometer, right? So the two wedges are spaced 2 centimeter initially, with 50 being at the center of it. So here you can see this is a transformer which is converting 220 volt into 6 volts at 2 ampere. 2 ampere of current is supplying at 6 volts, right? I have connected these two terminals with the electromagnets here, and see, the lower end of this electromagnet should be just above the wire, right? It should not touch it, and it should not be too far. Means the gap should be around 5 millimeters approximately, right? So what will happen when I supply this current to the electromagnet? Will get magnetized, and it will further what now, because what is there, alternating current, still it is alternating current, so it is moving like this. Means first 0 to maximum positive, and then falling back to 0, then going maximum in negative direction, then again falling. This is one cycle of the alternating currents. So while it goes 0 to positive, right? So this will attract, okay, this will attract the wire, and the wire will be moving up, right? Will be attracted toward the electromagnet. Then the current falls to 0, so it will get demagnetized, and will the wire will go back to its original position, right? And then again it gets magnetized with negative current flowing through it. Again it will get magnetized. So this way this wire will start moving, right? So at resonant frequency, the wire will start vibrating, up and down, and with maximum of oscillations, okay? Maximum oscillation will be achieved at a point which will be the resonant frequency, right? So while finding the resonant frequency, then we can calculate the frequency of the current that we receive, that by formula F is equal to nu upon 2, half of that, okay? And nu already we know, we have found for strings it is 1 upon 2L under root T upon M, right? So I'm starting with it. I'm keeping it on. Now switch the transformer to on position, right? And I will start increasing the distance between the wedges, so between the wire as well. So this is the wire. See, now the wire has started oscillating. you will see the vibrations. This is the maximum vibration, and we will note down the reading for the distance between the this the two wedges. It is 28 point. It is 28.9, and here it is 73.1. Okay, this is for increasing. We have increased the distance. One reading is increasing. Then we will take for the same mass, we will be taking it for the decreasing distance as well, right? So that if there is any error, that will be removed. And the mean value will give us one reading for a particular mass. Then we will keep on increasing the masses. We will add another 500. Then again we will find the resonance condition. Then another 500, and then another 500. Okay, so this is how we will get the L in that formula. Okay, that will be the length of this column. And for tension, already we have got here multiplying it with the mass with 9.8, we will get the tension, that is 9.8. And then mass per unit of the length of this. This is we have seen where we can get it by using the formula. We can use the formula, as well as we can find out the mass of this much of length of the table. So that way we can get the frequency of the alternating current that we that we see in our, and that will come out to be 50 hertz. Thank you.